Everyone, welcome to my channel. So in this video I'm going to introduce how we are going to solve this problem called find peak element. And before we start the content for this video, I would invite you to help subscribe this channel because it can really help this channel to grow. Thanks a lot. So let's get started. A peak element is an element that is strictly greater than its neighbors. Given an integer array nums, find the peak element and return its index. If the array contains multiple peaks, return the index of any of the peaks. So you may imagine that nums -1 and nums n as equal to negative infinity. So which means if the element at 0 or the element at the end of the array, it is larger than the neighbor, then we are going to treat it as peak as well. So let's see. So for this one, nums 1, 2, 3, 1, it is going to return 2 because this one, 3, with index 2 is a peak element. So let's see the constraints. It says the length of the array is not going to be empty, so it is between 1 to 1000, and the numbers within this input nums array is within the range of int 32. And also it says that nums I, like each of the neighbor, like each pair of the neighbor, is not going to be the same. Alright, so I think I pretty much understand the question, and currently the only edge case I can think about is what if the input nums array only contains one integer? Then we just need to return 0 as the index. Otherwise, I think there isn't too much room for us to figure out the edge case, but I would say the edge case I mentioned before can also be covered by general algorithm, I think. So there is a follow-up saying that can we implement a solution without logistic? Can we implement a solution with log complexity? The answer is yes. And if there is such follow-up, it makes me feel that we can use binary search to solve this problem. So essentially the brute force solution is we do a linear scan on the input array, but that would make this question to be too easy. So since there is some follow-up saying we can use some log complexity, so the algorithm is to change the original binary search and to apply binary search in a new environment. So let's go through this piece of code, and at the same time I'm going to introduce a solution. So the general idea is to use binary search to solve this problem. And for binary search, the goal for us to do is only to find the local peak. So for binary search, we have the left and right pointer. So we have the mate pointer, which is left plus right minus left divided by 2. So if the made nums at made is smaller than nums made plus 1, then it means that the mate point is on a slope, like from it's like a slope something like this, right? So like it's going, if it is going up, so it's a slope going up. Otherwise it is a slope going down. So if nums made is smaller than nums made plus 1, then it is it's a slope that's going up, so there should be a local peak within the right side. So we are going to have left as equal to mate plus 1. Otherwise, if the slope is like something like this, like the slope going down, then it means that there is a local peak on the left side. So we are going to set the right as mate. And finally, we just return left. So that's pretty much it, and the runtime is going to be log n, and space-wise it is constant. So that's it for this coding question. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.